Our question is to prove that the left-hand side is equal to our right-hand side, or that our right-hand side is equal to our left-hand side. So the question comes up as, which side do we start with? Are we going to start with the left and prove that it's equal to the right? Or are we going to start with the right and prove that it's equal to the left? So how we make that decision is by looking at both sides and seeing which one has more terms for us to simplify. So we are going to use the left hand side, which is cos 2x minus 2 plus cos x all over 3 sine x plus sine 2x. Now, we can see that our numerator is a cos double angle and our denominator is a sine double angle. And cos of 2x is equal to cos squared x minus sine squared x, 2 cos squared x minus 1, and 1 minus 2 sine squared x. Sine 2x is equal to 2 sine x cos x. So we need to figure out which of the three cos double angle formulas are we going to use in this question. Now, if you look at your right hand side, you can see that it has we can see that it has cos only. So we are going to use the double angle formula that only has cos, as opposed to using the one that has cos and sine, or sine only, because we only want to have cos in our numerator. So let's substitute that in. And our denominator, we just substitute our sine double angle formula. So we used our second one and our sine double angle formula. So all we've done so far was substitute. Now, let us simplify. We can see that -1 and -2 are like terms. So 2 cos squared of x plus cos x, -1 minus 2 gives us -3, and that is all over 3 sine x plus 2 sine x cos x. Now, we can see that our denominator has a common factor of sine x, and our numerator is a trinomial. So let us factorize our numerator and take out a common factor in our denominator. So our denominator, we take out sine x, that is going to give us 3 plus 2 cos x. Now, let us deal with our numerator. So we need to ask ourselves, what times what gives us 2 cos squared of x? Or in other ways, we can ask ourselves, what are the factors of 2 cos squared x? Now we know the factors of 2 cos squared x are 2 cos x and cos x. Then we ask ourselves, what are the factors of -3? We know the factors of -3 are positive and -1 and positive and -3. So let us use +1 and -3. If these factors don't work, we can swap them. We can put -3 on top and +1 at the bottom, or we can swap the signs until we get something that works. So going to cross multiply this. So cos x times +1 gives us positive cos x. 2 cos x times -3 gives us -6 cos x. When we add this up, we end up with negative 5 cos x, which is not what we want. Now, let us try to swap the signs and the values. So we'll keep on swapping and changing combinations until we get something that works. So let's use positive 3 on top and negative 1 at the bottom. So if we multiply cos x times positive 3, that gives us positive 3 cos x. If we multiply positive 2 cos x and negative 1, we end up with negative 2 cos x. From here, if we add both these terms, we end up with positive cos x, which is what we wanted. So all we're going to do is bracket them like this. So we have 2 cos x plus 3 and cos x minus 1. So as you can see, we almost have our right hand side. We have this cos x minus 1 and cos x minus 1. And we have sine x and sine x. So we're almost there. Now, let's have a look at what we have. We have 2 cos x plus 3 and 3 plus 2 cos x. That is basically the same thing. It's like saying 1 plus 2 and 2 plus 1. It's the same thing. So this is going to cancel this, and we're going to end up with cos x minus 1 all over sine x. And we can conclude that therefore the right hand side is equal to, or rather our left hand side is equal to our right hand side. So we have now proved that cos 2x minus 2 plus cos x all over 3 sine x plus sine 2x is equal to cos x minus 1 all over sine x.